Hello everyone, welcome to lesson 5-6, part 1 of 3. We are going to be working more with radicals. Today we are going to focus on adding and subtracting radicals. Okay, like radicals are just like terms. If you think back to the beginning of the year when we were combining like terms, they had to have the same variable and that variable had to be raised to the same exponent in order for us to add up those coefficients. Like radicals are the same, except instead of the exponent, it's the index, and instead of the variable, it is the term that's inside the radical, the radicand. So like radicals have to have the same index and the same radicand. Square root of 5 has an index of 2 and a radicand of 5. 3 square root of 5 has an index of 2 and a radicand of 5. And negative 4 square root of 5 has an index of 2 and a radicand of 5. Since those are all the same, those are considered like radicals. Unlike radicals, one of those will be off. So this one is square root of 3. It has an index of 2 and a radicand of 3. Then you go over to this one, square root of 3x. It does have an index of 2, just like this one, but the radicand is 3x, not 3. So those are not similar. This one is the cubed root of 3. So its index is different from both of these. So it is not like, those would be unlike radicals. Okay. So just keep that in mind as we're working with adding and subtracting radicals, because in order to add and subtract, both of the index and the radicand have to be the same. All right. So looking at the steps, first you have to make sure that radicand and index are the same. Then all you have to do is add the coefficients together, okay? One thing that you need to keep in mind is that if a radical does not have a coefficient in front of it, then we assume it's a 1, okay? And the last thing, leave the radicand alone. So you see how we have the square root of 5 here? That will not change. So let me show you how this works. We will, since our radicand and index are the same, we are just going to add the coefficients together. Okay, 3 plus 6 is 9. So our answer is 9 square root 5. It's as simple as that. Okay. All right, let's go to example number 2. Our radicands are the same, our indexes are the same, so we can add those together. Or in this case, we're subtracting. 7 minus 2 square root of AB gives us 5 square root of AB. Okay. Okay. All right. Now remember, if a radical does not have a coefficient, we assume there is a 1 there. So I'm gonna put an imaginary 1 or just a 1 there. And now the radicand and the indexes are the same, so we can add these together. If it helps put that 1 there, please put it there, because a lot of students will end up putting the answer as 3 square root of 3 because they forgot to add in that 1. Okay. All right, moving to example 4. Our radicands are not the same. Our indexes are the same, but our radicands aren't, but they both have to be the same in order to add them. So in this case, we can't add them. Our answer is just 8 square root of 5 plus 9 square root of 7. That's it. We can't go any further. It's exactly what it is. Okay. All right, example 5 looks scary, but it isn't. All of those fractions have a denominator of 5, so all you have to do is add up your numerators. So in looking at this problem, I see that the first 2 terms have like radicands. So I can add these 2 together. However, this one I can't, so that one is going to have to stay the way that it is, okay? So I have 4 plus 8 square root of 6r, and then bring the symbol in front of it, minus 6 square root of 2s all over 5. And then I would rewrite this by combining these two coefficients, 12 square root of 6r minus 6 square root of 2s over 5. And that would be my final answer. Okay. All right, moving on to example number 6. Both of our radicands are alike and both of our indexes are alike, so we can add these. I'm going to put a 1 there to remind me to add that 1. So we have 1 plus 2 cubed root of x equals 3 cubed root of x. Okay. All right. Moving to example 7, we have x cubed to the root of 5. Then we have 3x cubed to the root of 5, and I'm ignoring the coefficients right now. So these two are not alike. And then here we have x cubed to the root of 5. So the first and the third one are alike. So I can combine these two, and remember to carry the operation that's in front of the term with it. But I cannot include this one. That one's going to have to stay the way that it is. And I'm going to put an imaginary 1 here. Not imaginary, it's real. I keep saying imaginary. And I'm going to add the 1. Actually, I'm going to subtract 1 minus 7. X cubed to the root of 5, and then plus 3x cubed to the root of 5. And I get negative 6. Okay, and that is as far as I can go with that one. So there we go. All right, example number 8, both our radicands and our indexes are the same. I'm just going to add these two 1s here. So we get 1 plus 1 equals 2x to the root of 4. Number 9, our radicands and indexes are the same, so we can combine these. 4 minus 6 equals, I was thinking negative 2 when I wrote that, but 4 minus 6 is negative 2x squared to the root of 4. And there you have it. Notice I simplified my steps a little bit from what I was doing above. And number 10. Number 10, I cannot simplify any further because my indexes are not the same. So basically, this is your answer. All right. So this first page was all about adding and subtracting like radicals. We are now going to go to the second page, and we are going to add and subtract unlike radicals. All right. So when we are dealing with unlike radicals, our goal is to make them alike. We're going to factor out the radicals like we did in all 3 lessons of 5-5. And then we're going to see if once we factor them out, do they have the same index and the same radicand? And if they do, then we can finish up the problem by adding those together. If they don't, we have to leave it alone because it's as simplified as it's going to get. So the only additional step here is that you have to factor out your radicals. All right, so let's look at example number 11. We have 2 square root of 12, which can be factored out. And then we have 6 square root of 3, which cannot be factored out any further because that 3 is a prime number. So that one will stay the same. So the first thing I'm going to do is I'm going to take this 12 and I'm going to factor it out and rewrite this entire term, okay, after I factored it out. So I'm going to take 12, okay. Now I have 2 square root of 2 times 2 times 3, okay? So I just took these factored out of the 12 and I put them underneath the radical symbol. Now, if you remember from 5-5, we are going to, because this is a squared root, we're gonna pair it in groups of 2. And I only have one group of 2. So we bring that down or out of the radical symbol and multiply it with the coefficient on the outside. And then we're left with this 3 on the inside. So we just leave that there because it's not paired up with anything. And we end up with 4 square root of 3. And now I'm just going to bring this 6 square root of 3 down because I didn't need to factor it out at all. Okay. And we end up with, because we have the same radicand and the same index, we can now combine these. 4 plus 6 square root of 3 equals 10 square root of 3. And there we have it. Okay. And so that's how we're going to be solving all these problems. Okay. So going on to example number 12, 8 and 32 can both be factored out. So that's what I'm going to do with both of those. So we're going to start with 3 square root of 8. And I'm just going to take my 8 and factor it out. Okay. So then this becomes 3, and then 2 times 2 times 2. Okay. Then I'm going to factor out my 32. And we've been doing this a lot, that most of you could probably memorize that 32 is factored down to 5 2's. Okay. So then I'm going to add that 5. And then we have 2 times 2 times 2 times 2 times 2. Okay. All right. Now what I'm going to do is I'm going to pair up my numbers. Again, this is square root, so I'm going to pair up groups of 2 here. And I'm going to pull that group of 2 out and multiply it with the 3. And we're left with just a 2 on the inside. So that's going to stay there because it's not paired with anything. And then do the same thing with the other term. I'm going to group up my pairs of 2's, and then I have 1 left over. So it looks like we're going to have the same index and the same radicand. So 5 times 2 times 2, square root of 2. Okay. Now I can simplify those further. I have 6 square root of 2 plus 5 times 2 is 10 times 2 is 20 square root of 2. And that gives us 6 plus 20 equals 26 square root of 2. And that would be our final answer. Lots of numbers. Okay, number 13. We have 275. So let's do 200. 10 and 20. 10 factors to 2 and 5. 20 factors to 2 and 10. And then 10 factors to 2 and 5. Okay. So the square root of 200, we end up with 3 2's and 2 5's. Plus whatever 75 factors out to. So I'm going to factor out 75 over here. Okay, so we end up with 3 times 5 times 5. Okay, now I'm going to pair up my numbers. So I end up with a group of 2s and a group of 5s here and a group of 5s here. So I'm going to pull those groups out. So 2 times 5 square root of 2 plus 5 square root of 3 gives us, this is 10. So, well, let me write this out. 10 square root of 2 plus 5 square root of 3. Oh, they do not have the same radicand, so that's as far as we can go. We basically just factored them out. And this would be your final answer. Okay, moving on to example 14. We have 48 and 75. Now 75 I already did right here for this problem, so I'll just do 48 and then we'll write this out. So 48, we have 4 times 12. Okay, all right, so let's write this out. D square root of, so 48, we had 1, 2, 3, 4 2s. And 1, 3. Make sure that's right. 1, 2, 3, 4, 1, 3. And then we cannot forget this D on the inside. Okay. And then minus. And the 75 has already been factored out over here. So I'm just going to write that here. 3 times 5 times 5. And we can't forget the 3 D's right here. Okay. And I'm writing a little bit short on space. So I'm just going to write those really close together. All right, now I'm going to pair those up. Okay, so here I can pull out 2 2s. So it's going to be 2 times the D on the outside. And then I have a 3 and a D left on the inside. On this one, I can pull out a 5 and a D. And I have a 3 and a D left on the inside. So I do have the same radicand and the same index. So 4D square root of 3D minus 5D square root of 3D. Okay, so now make sure that your coefficients are also like terms. So 4D and 5D, they both have the same variable raised to the same exponent. So those are like terms. So I can go ahead and solve that. 4D minus 5D is a negative 1D, or we don't have to write -1, we could just write negative D square root of 3D. If you did put a -1 there, it would not be wrong, but you don't have to. Okay, moving on to example 5. Okay, this one has parentheses with squared on the inside, so I am going to rewrite this one. 8 squared x squared, okay? All right. Now I'm going to factor out my 8. And I end up with a group of, I have 3 2s here, but since 8 is squared, I need to double that. So let's see. I have 2 times 2 times 2. That was my first 8. And now I have to do 2 times 2 times 2 again for my second 8 because it's being squared. And then we don't want to forget our variable, our 2x's in there. Okay. And then this one, there's not much factoring that's going to go on. We just have two x's on the inside, and we really can't group any of those together. So we could leave it as x squared. Now I'm going to pair up my groups. Now we're looking for groups of 3 this time. So I have a group of 3 and a group of 3, and I have 2 x's left over. Okay. So I end up with 2 times 2 cubed root x times x. So 4 cubed root of x squared plus 3 cubed root of x squared. And look at this. We have the same radicand and the same index, so we can add these together. So we end up with 4 plus 3 equals 7 cubed root of x squared, and that would be our final answer. All right, example 16 is very similar to this one. So I'm going to rewrite this as 27 squared x squared. Okay, and I need to factor out both my 27 and my 64. So 27. Okay, now because 27 is being squared, I have to double my number of 3's. Okay, so I'm now not going to have 3, but I have 6 3's. 3. And then don't forget your variables. Okay. And now I'm going to do the same thing with my 64. Okay. So I am going to factor 64 right here. We have 8 and 8. Now with 64, it's not being squared, so I'm just going to have the 6 2's and the 2 x's. Okay. All right, now I'm going to pair those up. Actually, I'm going to circle groups of 3 because we have an index of 3. So group and group, group and group. Okay. So on this one, I can pull out my 2 3's. On this one, I could pull out my 2 2's. And simplifying that, I have 9 cubed root of x squared minus 4 cubed root of x squared. They have the same like radicals and like indexes, so I can just subtract. And we end up with 5 cubed root of x squared. Okay. All right, 2 final problems here. All right, number 17, find the perimeter of a rectangle if the length is 6 square root of 16 and the width is 3 square root of 121. Okay, so we have a rectangle here. Let's see, we have 6 square root of 16, and then we have 3 square root of 121. Okay, so the first thing that we need to do is factor these out so that we can see if they have like radicals and see if we can add them all together. So first we have 6 square root of 16, and I know that the square root of 16 is 4 because 4 times 4 gives you 16, like this. So I just pull that 4 out and I have 6 times 4, which is 24. So I know that this one is 24, which means that this is also 24. Okay. Now we are going to factor out 3 square root of 121. Now I also know that the square root of 121 is 11. So I'm going to pull those out. And we can pull that 11 out and we end up with 3 times 11, which equals 33. So this is 33 and this is 33. Now to find the perimeter, right here, we're going to add all of our sides together. So 24 plus 24 plus 33 plus 33, 48 plus 66 gives us 114, and our units are inches. Okay, 144 inches. All right. So we're on our last problem. Now we have some pretty large numbers here, 800 and 648. So they have a rectangular swimming pool that has the length of the square root of 800 feet and a width of square root of 648 feet. What is the perimeter? So again, we're looking for the perimeter. So I'm going to do the same thing that I did up here. Okay, and I'm going to factor those two out. So when I take, let's see here, this one required a lot of factoring. So I'm going to take 800 over here, 10 and 80, 2 and 5, okay. And then I'm going to go ahead and factor out 648. And we end up with, I know that 64 and 8 are both divisible by 8 evenly, and so I'm going to divide that by 8, and I end up with 81. Okay. So I need to figure out what the radical turns into here. So I'm going to take my square root of 800 and write it all out right here. So I have 1, 2, 3, 4, 5 2s, and then 2 5s. So there we go. Okay. And then for my 648, I have 1, 2, 3 2s and 1, 2, 3, 4 3s. 3 2s. Four 3s. Okay, so let's go ahead and factor those out. So I can pair up my numbers. And then pair these up. Okay. So here I have 2 times 2 times 5 square root of 2. And here I have 2 times 3 times 3 square root of 2, because I have, in both of them, I have a 2 left over. So I have 20 square root of 2, and then I have 18 square root of 2. Now that I factored those down, we can figure out the perimeter. So 648 became 18 square root of 2. So that's 18 square root of 2. 800 became 20 square root of 2. Okay, so we just have to add all those together. So plus 20 square root of 2 plus 18 square root of 2 plus 18 square root of 2. So I just strung those all along. So really, I could just add up all my coefficients. 20 plus 20 plus 18 plus 18 square root of 2. So I have 40 plus 36. So this is going to give me 76 square root of 2 feet. And there you have the perimeter of that swimming pool. was a lot of work for that one. So, okay, that ends our first lesson in 5-6, adding and subtracting radicals. If you have any questions, please give me a call, and I will see you all later.